and limits of functions. So recall what we did in previous videos. What did we do? We defined what the limit of a function is. So I recall that definition immediately. A number L is called the limit of a function, say f x as x tends to, that means as x approaches a given value, say a, if for all positive number given, you can get another positive number that depends on the given one. That's the for epsilon positive, there exists delta that depends on epsilon, which is also a positive number, such that for any element of the domain of the function f, anytime this inequality is satisfied, that means f at x negative L will be less than epsilon. So a number L that satisfies this inequality is what you call the limit of the function f at x. And then when this happens, we write this way. So we write that L is the limit of f of x as x tends to a. That's what we call the limit of a function as x approaches the number a. Okay. I need to emphasize something here. Actually, a few things. One is this. The fact that I put 0 less than this simply says that x is different from a. That means, and then if x is not a, it means that the function f may not even be defined at the point a. So f of a may not exist. So these are two facts we will take from here. Another fact that we have to take is that this number L is unique. So L is unique, meaning the limit of a function, when it exists, is necessarily a unique number. So you cannot have two different numbers being the limit of the same function. So these are three facts we have. We will see another fact very shortly following these 1, 2, 3, so I will list the next one immediately. Let me summarize the facts from the definition. Number one fact is this: x is not equal to a, which is what we have seen. Number two is that f of a may not exist. Number three is that limit of f at x as x approaches a may also not exist. So it is not compulsory that given a function the limit must exist. Not necessarily true. Number four is that even if f of a exists and limit of f at x as x approaches a also exists, it's possible that f at a is not equal to the limit of f of x as x approaches a. So these are important facts we should bear in mind anytime we deal with limit of functions. Alright, for example, let me start from here. A case where f at a does not exist. So I take a point and then I want to see. This is very crucial for the next topic we're going to learn, which is continuity of a function. So we shall see, in that case, what should be the situation with f of a. Alright, so if I give this example, I give you f of x is 1 over x. And I want to compute the limit of f of x as x approaches 0. You can see immediately here that f of 0 does not exist. However, but we can compute the limit of this function as x approaches 0, even though f at 0 does not make sense. And that says here that, so the fact we are trying to bring out here is that the point A you're dealing with is not necessarily going to be a member of the domain of your function before you can speak about the limit of the function as x approaches the number A. So that's the point I'm making here. So, but for the discussion we have here, I'm going to keep it here. As you progress further in your career, you will see that it suffices for this point A to belong to what we call the, to be a member of the derived set of the domain of F. So if it is a member of the derived set, then we are good to go. But then don't bother about that now. This is first year, and then I know my audience, so they are still coming up. So we just keep it at the fact that the point A is not necessarily an element of the domain of your function before you can compute the limit as x approaches A. So that's what you take from this discussion. Okay.